Next topic in module 5 is wave equation from Maxwell's equation for uniform plane waves. So we can assume an electromagnetic wave which is traveling in free space. So consider that the electric field, it is in the x direction, magnetic field is in the y direction, and in the z direction the wave is propagating. So we know that specifically, that is the conductivity is equal to 0 and charge density rho v, volume charge density, is also 0 in free space. So we are going to derive starting from the Maxwell's first equation. So what is Maxwell's first equation? Del dot D is equal to rho v, and we know that for free space rho v is 0, so you can write del dot D equal to 0. Also you know D is epsilon E, so substituting rho del dot epsilon E is equal to 0 or del dot T equal to 0. That is your first equation. Now say from Maxwell's fourth equation we know del dot B equal to 0. Now what is B? Mu into H. So del dot H is equal to 0, or simply del dot H is equal to 0. That is your equation number 2. Now coming back to Maxwell's second equation, del cross E is equal to minus dou B by dou T. This dou by dou T you can also write as j omega, right, in frequency domain. So minus j omega into B. Instead of B you can substitute mu into H, or simply you can write del cross E is equal to minus j omega into mu H. That is equation number 3. Now coming to Maxwell's third equation, you know del cross H is equal to j plus dou D by dou T. J, you know, it is sigma E. This dou by dou T you can substitute as j omega. D you can substitute as epsilon E. So you can write del cross H is equal to sigma E plus j omega epsilon E. Grouping these two, sigma plus j omega epsilon into E. Mark it as equation number 4. In equation 3, you take curl on both sides. So we know del cross E is equal to minus dou B by dou T. This minus j omega mu H. So del cross A is equal to del cross minus j omega mu into H. Or you can simply write it as del cross E is equal to, take this minus j omega mu outside, del cross H. So mark it as equation number 5. Now we also know a vector identity. Curl of a vector is gradient of divergence of that vector minus Laplacian of that vector. So apply that identity to this vector E. So you get del cross E is equal to grade del dot E minus del square E. So mark it as equation number 6. Now you can see equation 5 and equation 6 LHS are same. So you can compare. So you get grade div E minus del square E is equal to minus j omega mu into del cross H. Mark it as equation number 7. Now we are going to apply our equation 4. What is our equation 4? We are going to substitute. Equation 4 is del cross H is equal to sigma plus j omega epsilon E. That we are going to apply to this equation. So this part we are going to substitute. So del div E minus del square E is equal to minus j omega mu into, instead of del cross H you substitute sigma plus j omega epsilon E. Mark it as equation number 8. Now we are going to apply equation 1 to equation 8. What is our equation 1? Del dot D equal to 0 or del dot E equal to 0. So we are applying that here. So this term goes to 0. So this is 0 minus del square is equal to minus j omega mu into sigma plus j omega epsilon E. Or simplifying, you get del square E minus j omega mu into sigma plus j omega epsilon E equal to 0. Or this term together, that is j omega mu into sigma plus j omega epsilon, we can group together to form a constant which is gamma square E. That is known as the propagation constant. So you can write del square E minus gamma square is equal to 0. This is known as the wave equation in terms of electric field intensity E. This equation is number 9. And gamma square is known as propagation constant. It is given by j omega mu into sigma plus j omega epsilon. Mark it as equation number 10.